Okay, the question says, assume that 32 kilobyte program is run on a computer having 32 kilobyte physical memory, right? So 32 kilobyte program will give you the idea of the logical memory. Right? And 32 kilobyte of physical memory, it says straight away, right? So logical memory is 32 kilobyte, physical memory is 32 kilobyte as well. So page size of the system is 4 kilobytes, it says. So from that, you can assume or suggest frame size as well. Why we are suggesting it like that? Because we know size of the page is equal to size of the frame. Logical memory, they had these pages. So from the same size in the physical memory, they had the same size of frames. Right? They are not different. So the page size is equal to the frame size. That is why offset bits are going to be same in both the addresses. Excuse me. Right. So those factors are there in the question. Okay. So moving forward, it is saying the page table of this process at a particular time is shown on the table below. Right. So it has page number, frame number, and present absent things. Right. Then only a few selected fields of each page table entry is shown. Right. So these are called the page table entries. And so it is a one big table. So only a selected fields is selected by them. That's what they are saying. Then it says the frame number is indicated in binary. Okay, so 110, all these things, 110, 001, 010, 100, yeah, all these things are indicated by binary. Then here comes the important part. The virtual address on page 0 are from 0 to 4095, and on the page 1 are from 4096 to 8191. Right? So that means if we take this as the first page or the 0th page, right? It is having the virtual address of 0 to 4095. That means this may contain lots of memory slots. Right. So the very first one, and the very last one, addresses are given. One is given, this is considered as 0. This is considered as 4095. Right. So they were talking about the second page as well. So this is going to be the second page. I'll put a different color for the second page. Right here, the first address they say it is from 4096. Right, so here the last address is going to be 8191. Then people just excuse me for a moment. Yes. Yeah, for you to understand about this number magic, I'll show you a simple example. ඔගොල්ලෝ මේක දන්නවා, right? The only thing is you are not getting it to your mind. Think about a page which contains 4 bits. If this is a page, so how we are going to name this particular page? Like 0, like 1, like 2, and like 3. Right? So those will be the numbers. Right? So if it is the first page, now let's think about a second page. So the second page obviously going to be 4, 5, 6, and 7. Right? So if like in this example, I consider only 4 bytes are inside one particular page. Right? So these are the decimal values which I'm going to represent. Right? But you know, the address is not specifically or like not generally written by decimal values. It will be referred as a binary value, right? So all you have to do is you have to convert this decimal value into binary value. So for that, you need to know how big your address is, right? So the same thing happens here. So they are telling us how the numbers or how the addresses are going to go in decimal values. Right? So if we extract any of the address, convert it into the binary, it will give you the total address inside it. Did you get the idea, people, regarding these numbers? Yes, people? Did you got the point? Okay, how about others? Yeah, and it's like this. Bengalindi, now think about, now simply think about, think it like this, right? I'm taking this as the logical address. I'm sorry, this as the logical memory. So my logical memory, if you consider this small square considered 1 byte, so my logical memory has 8 bytes, right? So if I'm going to name those things one by one, like using the decimal values, I'm going to write it like this: 0, 1, like it's going to be named page by page, right? So 0, position 0, position 1, position 2, position 3 will be there. So it always starts from 0. Why we say it starts from 0? Because when we convert this into a binary, we are going to indicate 0, 0, 0 over here. When we convert this into the 1, we are going to indicate 0, 0, 1 over here. When we consider 2, it's 0, 1, 0. When we convert into 3, it's 1, 1, 0. I'm sorry, 0, 1, 1. Right? So instead of writing the binary value, I can represent the same address block using its decimal equivalent. Right? So why I wrote these things in 3 bits to represent 8 empty locations? I need at least 3 bits. Are you getting it, Lalindi? All right, okay, great. So the same way the things are going to happen here as well, right? So that is what they are explaining from here. Page 0 are from 0 to 4095, and page 1 are from 4096 to 8191. It can be bit එකෙන් bit එකට දාලා තියෙන addresses වල decimal representation එක තමයි they have given here, right? So then it says the present absent bit indicates the validity of the entry. If this bit is 1, the entry is valid and can be used. If it is 0, then the relevant virtual page is not in physical memory, right? So that means when the present absent bits are indicated as 0, they are not presented in the physical memory, right? So when these things indicated by 1, it is talking about the virtual page, right? Not the physical memory. So present absent bit indicates the status of the page. So if it is 1, that page is being occupied inside some particular frame, right? And if the present absent bit is 0, now that page is not there inside the physical memory, or like the physical or like a particular frame, right? So that is what they say. The present absent bit indicates the validity of the entry. If the bit is 1, the entry is valid and can be used. If it is 0, then the relevant virtual page is not in physical memory, right? So now the question that they were asking, assume this program requires accessing virtual address 8200. To which physical address will it get transformed? Right? That means there is a logical address called 8200. Right? And to which particular physical address that it is being converted into. So ඔය අහන්නේ අපි අර ලස්සන diagram එකක් යන දන්නේ නේද? ලස්සන උනාට ටිකක් complex diagram එකක් යන්නේ. අන්නේ diagram එකෙන් අපි convince කරන්න හදපු මෙන්න මේ concept එක. Now here we have took a particular logical address and matched it into a physical address. How did we match? With the help of the page table, right? Page number එකට corresponding තියෙන frame number එක match කරලා. So we take that, right? So that is what they are asking. දැන් ඒගොල්ලෝ කියලා තියෙන මේ logical address එක තමයි ඕගලන්ට 8200 කියලා දීලා තියෙන්නේ. You have given there is a logical address called 8200. So they are asking to which kind of physical address that they are going to convert. Now, is the situation clear with you all? Okay. How about others? Yes, people. How about others? Are you getting this or not? Right. Okay. Okay. Right. So now let's jump to the question. So what are we need to do? How we are going to match it? So it is easy now. We have given the virtual address. So all we have to do is we have to extract 8,200 and see what is the nature of our address in ones and zeros. Right? Then we have to figure out to which kind of a frame number that it can be converted. Right? So to that, what do we need? We need to write 8,200 in binary. And then in here, you have to be very careful when you are writing the 8,200 in binary. It's going to represent a particular virtual address. And you have to be sure how much bits or like how many bits are there in the virtual address. Right? So if it is done, the calculation is nothing. Right? So 8,200 must be converted into the binary and should be compared with the particular address. Right? So then we can see for the portion of the page number, which portion of frame number is going to be replaced. කලින් පෙන්නපු diagram එකේ ඔයගොල්ලෝ පොතේ ඇඳගත්ත diagram එකේ ලොකු diagram එකේ උනේ තේ දෙන්නේ. Page number portion is detached. According to that, a frame number portion is attached. Right? How we are going to find how many bits are there in the address? Address එකේ bits කීයක් තියෙනවා කියන එක හොයාගන්නේ කොහොමද? Logical address එකේ. Yes. How we are going to find the number of bits in the logical address? Yes, people, go through your equations and tell me what is the equation that we need to use to find total number of bits in the memory address. Yes, people, any clue regarding that? What is the equation that is going to tell you how many bits are there in the logical address? For your convenience, I will show you the equations as well. Oh, there you go. Now, which equation? Yeah, Osanda, number of pages into page size will calculate you the logical address space, Puda. But from that equation, you won't be able to find out how many bits, number of bits are there in the in the logical address. Yeah, Lalindi, that's the correct answer. That is correct. How about others? Yes, the equation should be this. My logical address space is equal to 2 to the power number of bits in the address. So we know logical address space. It says 32 kilobytes. Right? And the equation equals the 2 to the power total number of bits in the address. So that is what we need to find out. Right. So now you all together, by applying that, tell me how many bits are there in the memory, in the logical address. Like what is the logical address space, or like the capacity of the logical memory? What should be? Yes. What should be the answer for that? Logical address space එක කියලා අපි අල්ලගන්නේ කවුද? මේ අපි ලිව්වේ මෙතන logical memory කියලා පටන් ගන්නකොට. Right? So by resolving that, using that, just tell me how many bits are there to represent the logical memory address. Yes, people. Try to do it. Okay, right. Yes, Lalindi, that's the answer. Osanda, not that. I know what you have done. You have taken 32 as 2 to the power. That storage is in kilobytes. First, you have to convert that into bytes. They haven't mentioned anything about byte addressable and bit addressable thing. So since they haven't mentioned about anything, we are going to consider it as a byte addressable one. Osanda, did you got the point? Okay. Now give it a try. Everyone else, please give it a try. It's a simple equation that you have to solve, right? And let me know how many bits are there in the logical memory address. Yes, everyone. Okay, I'm receiving an answer. Yes. Nalindi, yes. That is correct. Yes. What was the answer previously? Yeah. Osanda, it's not 18 පුතා. ඔයා bit වලටම convert කරලා තියෙනවා. It should be converted up to the bytes only පුතා. Right? Now see how we are going to find that out. Right? So the equation is, what's the equation? Logical address space equals 2 to the power total bits. So logical address space means what? The logical memory capacity it means. So it's 32 kilobyte equals 2 to the power total bits. So since they haven't mentioned us anything about byte addressable or bit addressable, this is going to be converted into bytes. So 32 kilobytes, once it is converted into bytes, happens what? 32 means 2 to the power 5. For this conversion, we need 2 to the power 10. Right? So that means altogether 2 to the power 15 bytes equals 2 to the power total bits. Right? So how it's going to be? Yes, Asanda, that should be 15. Right? So we are going to say, therefore, there are 15 bits in the logical address. Right? So that means you are going to represent any particular address in this logical memory using 15 bits. Now try to represent 8200. Why we are try to represent 8200? The question asks, what is the virtual address 8200 convert into when it goes to the physical memory? So you try to represent 8200 using 15 bits. Then after, you know how much is there. You have to calculate how much is there for the offset. Then you have to divide the offset and the page number. Then when you know the page number, you can figure out what kind of a frame number that you are going to receive. Give it a try. Give it a try, people. Now you extract the 8200 and then find me the number of bits which represents the offset. To find that, we can use what? The page size. It is given there, saying 4 kilobytes. Yes, that's correct. Pasanda, very good. That much of bits are there in the offset. Very good. How about others? දැන් ඔසඳ බලන්න ඔය ඇඩ්‍රස් එකෙන් offset කෑල්ල අස් කරන්න 8200 කියන එක න එක්ස්ට්‍රැක්ට් කරලා ඔය offset වලට දැන් bits ගණක් හොයාගත්තනේ. That is right, Kalindi. So you leave out that bits for the offset and see what is there to represent the page number. Page number එක represent කරන bit pattern එක මොකක්ද කියලා හොයාගන්න. ඔය 8200 කියන address එකේ page number එක represent කරන bit pattern එක මොකක්ද කියලා හොයාගන්න. Okay, Kalindi. Now find the corresponding frame number. If this is the page number, now page numbers are given as decimal values. तर බලන්න ඔය කියන කෙනාට equivalent decimal value එක බලලා ඒ decimal value එකට corresponding frame number එක හොයාගන්න. Yes, Lalindi, that's correct. So what is the corresponding frame number? You can find it from the page table. Absolutely. So what you have to do is take out the page number part, replace the frame number part. Does it make any difference, Kalindi? It does not. So the virtual address 8200 is going to convert to the same physical address, which is 8200. It is because of the corresponding frame number though. If it changes, it's going to change. Right. So yes, here I'm clearing things out. So what we have done is first we have determined how many bits are there in the logical address. So we found out there are 15 bits in the logical address. Right? So I'll draw a 15-bit logical address over here. So we got a page number and the offset. Now we know there are 15 bits in the logical address. Now what are we going to do is we are going to figure out how many bits are there in the offset. මොකද දැන් අපිට උවමනා වෙනවා to find out the corresponding frame number. මේ frame number එක හොයාගන්න ඕනේ අපි. මොකද map කරනකොට වෙන්නේ page number එක detach වෙලා එතනට frame number එකක් fix වෙන්න ඕන. So to find the frame number, we need to know what is the corresponding page number. To figure out what is the corresponding page number, we have to extract 8,200 and we have to represent it using 15 bytes. Then we have to leave out the offset part, right? So whatever is left will be considered as the page number, right? So when 8,200 is converted, කොහොමද 8,200 ඉක්මනට හදාගන්නේ? We can consider the place values. Right? So when we are considering the place values, I'm going to write the place values for 15 places, right? So it's going to be, place values are going to be 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 4,000, I'm sorry, 2048, 4,096, then 8,192, finally the 16,384. ඔසන්ද එතන පොඩි මිස් එකක් වෙලා තියෙනවා. බලන්න පුතේ මොකද වෙන්නේ කියලා. Right? So now I got 15 places, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how I'm going to perform 8,200 here? You can have it by dividing by 2 and you can take the binary value here, right? So without that, you can go on this particular manner as well, right? So I need a 1 over 8, like under 8,192. I need another 8 bits to create 8,200. So I need 1 over here under the 8. Rest of the bits are going to be zeros. Right? So now from this we have to leave out the offset part, right? මොකද page number කියලා කියන්නේ මුලින් තියෙන කැලල, offset කියන්නේ ඊළඟට තියෙන කැලල. So offset එකේ bits ටික අයින් කරාම we can find out how many bits are there for the page number, right? So how we get to know how many bits are there for the offset? Page size is given, right? So we have what? An equation like page size is equal to 2 to the power offset bits. So page size is 4 kilobytes equal to the power offset bits, right? Then 4 kilobytes means what? We have to write it from the bytes. So 4 kilobytes into the bytes. So 4 is taken as it is. For this, we need 2 to the power 10. So 4 can be written as 2 to the power 2. right? So this will equals 2 to the power offset bits. Therefore, offset bits equals 12, right? The 2 to the power offset bits is equals to 2 to the power 12, right? So that means from the address that we have extracted, we got 12 bits for the offset. So this is going to be the offset. And this part is going to be the page number. Anna Hariosanga. Right? So now we know page number is 010. Now move to the question. So now in our page table, we have two columns. One column is page number, the other column is frame number. Right? එතකොට map වෙනකොට page number එකට corresponding frame number එක map වෙනවා කියලා ගන්න පුළුවන් මේ එක කියන එක fix කරලා තියෙන තැන්වල. right? මොකද එක තියෙන තැන් තමයි valid entry එකක් කියලා අපි සලකන්නේ. 0 එක valid කියලා අපි අරගන්නේ නැහැ. So then what we have to do? Page number pattern was 010, right? So page number එක 010 කියලා කියන්නේ. So the page number equals 010. This is in binary, no? So when it is converted into the decimal, this indicates 2. Right? Now, in your question paper, page number 2, maybe in page number 2, 2 වලට corresponding frame number 010. Right? So 2 කියන එක්කෙනාගේ corresponding frame number එක මොකක්ද? 010. So that means what's going to happen? Page number 010 is going to replace by the frame number again 010. නේද? මෙයාව අයින් කරලා frame number එක තියෙන්නේ 010 කියලාම තමයි. That is possible. මෙයාව තමයි එතකොට replace කරන්න හදන්නේ. Right? So what's happened to this value? Will it give you a new value? Or will it give you the same value? It's the same. Yes, Lalindi, it's the same. Right? So you can do these workings on your rough paper, right? You really don't have the room to do all the calculations on the space that is given to you. So you'll do it and you write only the answer, 8,200. Okay, people, is this clear? Yeah, how about others? Is this clear? Right. Divyanganadua, Duli, how is it? Okay. Right. So now you can write this down. Right. We will start doing our calculation from here. So you can start writing it. Let me, let me do a small change here. You can start writing. Yeah, you may write it like this, people. So it will be much clearer for you. Let me know when you're done, people. People, I'm moving the screen a little bit upward. If you miss anything, just let me know. I will show it to you. And I'm writing a conclusion over here. Right. So something like this. Now, in the examination, you don't need to write this explanation, people. I'm just writing here for you to understand it. Right? In the examination, just writing the 8,200 will give you the marks. You don't need to show the calculations as well because they haven't asked any. Right? They only provide 2 lines for you to answer. So they are just expecting something straightforward. So you do the rough work in your rough paper and then you just put the answer. Okay, let me know when you are done, people. One is done. How about others? All right. So people who have done, I have an extra question for you. Right? Here comes the my question. Right? Okay, so this is my question. Find the physical address of the virtual address 16,400 from using the same page table. Okay, try it out, people. දැන් ඔයගලන්ට calculations කරන්න නැහැ. calculations ඔක්කොම කරලානේ තියෙන්නේ. ටක් ගාලා convert කරලා offset එක අයින් කරලා frame එක බලලා page එක බලලා page එකට corresponding frame එක බලලා, so you have to build up what's the answer, right? Physical address එක මට decimal වලින්ම දෙන්න, in decimal. ළමයි තප්පරයක් ඉන්න. I need to confirm whether anything have went wrong. Okay, hold on. Oh, no problem, no problem. Lalindi, yeah. That's correct, Dua. Well done. And take the answer in decimal, Dua. Right? Yes, others? How about your answer? අපි මේ උඩ කරපු විදිහමයි. ඒ කියන්නේ දැන් calculations කරන්න නැහැ. address එක extract කරා. Take it away. Yes. Lalin, that's correct. That's correct. Yes, Osanda. Yeah. The one you have chosen is correct, Uda. Then ඔයා page number කෑල්ලට ඒ frame number කෑල්ල fix කරලා then you find what's the value of the entire address. Right? ඒ කියන්නේ ඔයාගේ virtual address එකේ page number කෑල්ල වෙනුවට frame number කෑල්ල දැම්මම total address එකෙන් කීය දෙන්නේ කියලා හොයන්න. ඒක තමයි අහන්නේ. Yeah, why I am asking you to try on this. Now, it is the way that the rest of the questions are being asked in the examination now, right? So starting from 218 to 19 has the same question. 220 is having the same question, right? No, this is 19, no? So 20 has the same question. Others? What are the answers? Yes, Nikini, Duli, Divyangana. How is that? If it is still not getting with you, just tell me. I'll brief again. Yes, people. How's the situation? Nikini, how was it doing? Are you still doing it, or are you still are you struggling? Right, okay, right, okay. Duli, how about it? Do you need more time? Or are you struggling? And Divyangana? Yes, Divyangana Dua, do you need more time? Duli? Yeah, Duli, it doesn't matter though. The memory calculation part will be sufficient, but you'll capture the stuff, right? Okay, Divyangana, how about you? Right. හිතන්නේ දිව්‍යාංගනා දුවට communication issue එකක් වෙන්න ඕනේ, right? Okay. So I'll discuss. And Duli, Nikini, plus Divyangana. Now I'm specific. I'm specially talk to you people, right? So I'm going to do it now. So the question was, find the physical address in decimal of the virtual address 16,400. Then අපි කලින් හෙව්වේ it's the 8,200, no? So how we find the 8,200 physical address? We extract the 8,200. We found the portion of the page number. Then that particular page number is matched from the page table to the corresponding frame number. Then we represent what's the frame number is, what the final answer is. So same thing is going to be done, right, for this one, right? So the virtual address ඔසන්ද decimal එක ගන්නකොට පොඩ්ඩක් පැටලලා තියෙනවා. බලන්න. Right? So the virtual address we can say it is 16,400. That is the virtual address. Right? So what I'm going to do is I'm going to extract this 16,400 to recognize what is the page number part, right? So when I'm extracting 16,400, it's going to be 1. There are going to be how many zeros? 9 zeros. And another 1 and 3 zeros. That's correct. That's correct, Osandra. Right? Actually 4 zeros. Right? Now we got 15 digits, 15 bits over here, right? See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So that means the total, the full address is there. It's a 15-bit long address. Yeah, Duli, Divyangana, Nikini. Did you get this? I have to make a correct. Right? Duli and Divyangana, how about you two? Right, okay. Right, great, Divyangana. Now, what we have to do? We know from the previous calculations, the offset contains 12 bits. So the page should contain 3 bits. Then අපි කරන්නේ මොකද්ද? මෙතනින් වෙන් කරගන්නවා. Right? So this part is the offset. This part is the page number. Right? So now what we are going to do is we are going to see the page number and the corresponding frame number from the page table, right? So our page number is what? 100. This 100 in decimal, it's going to represent 4, right? So corresponding frame number is going to be what? So page number එකට එන්නේ 100. ඒ කියන්නේ 4 යා represent කරන්නේ. So අපි page table එකෙන් බලනවා what is the corresponding frame number for 4. So 4 අපේ page number එක උනේ 4. So the corresponding frame number is what? 011. Right? Again, Duli, Divyangana, Nikini, did you get this? Okay. Duli and Divyangana. All right. Duli. Okay. Now what we are doing, it is a simple thing that we have to do. Now we are going to take out the page number part and we replace the page number part from the frame number part. Right? So what are we going to do? We are going to write therefore physical address, right? So for the corresponding page number, the corresponding frame number was 011, right? Page table එකෙන් අපි බැලුවම අපිට තෝරගන්න පුළුවන් වුණා. 4 කියන කෙනාට corresponding තිබ්බේ 011. So what are we going to do is we are going to replace 011 for the page number. And rest of the things are going to be the same. That means you are going to have how many zeros? 7 zeros. So the same offset that we are writing. 7 zeros, 1 and 4 zeros. Right? So now since this is the physical address, the blue color part is named as the frame number, not the page number. This is the frame number. And this is the offset. Right? So this represents this decimal value, the entire binary value represents 12,304. I'm sorry. In decimal. So that means 16,400 virtual address will be mapped to the 12,304 physical address. Yeah, is that clear? Duli, Divyangana, Nikini, is that clear? Right. Okay. Copy that down. and we'll do another, right? Then හැමෝටම කරන්න පුළුවන් එතකොට. Duli and Divyangana, is it clear? Right, great. Divyangana Dua? Okay, okay. Divyangana, last part means the way that we have figured out the decimal part or the frame number replacement part. මෙතන ආපු හැටිද දුව? Decimal. Okay, okay. It is easy දුව. Divyangana, you know about the number system conversions, right? Are you familiar with it? How to convert a binary value into a decimal value? Right. So Divyangana, it's this, simple as this. So I'm taking the place value of these. So it is 1, 2, 4, 8, 16. So this is 32, 64, 128, 256, 512, 1024, 2048. This one has 4096. This one has 8196. Right? So to have this 12,304, we are considering the place values which has 1 inside the memory address. So 12,304 is given by 8,196, 4,096 plus 16. Is that clear, Divyangana? Right. Simple as that, right? Right. No worries. No worries. Hari. Then ලියාගන්න ඊළඟට තව එකක් හදමු. එකක් හැදුවම දැන් හැමෝටම එතකොට පුළුවන්. Then after we can try the 2021. And people, we are starting the physical classes in a very slow manner now, right? So I'm taking my 2021 crowd by next week, only the 2021, right? So my 2022 crowd, I'm expecting to take them within 1 or 2 weeks, right? So let's keep our day or like our gathering day by the start of January, right? Our sati tunak wage ne yanna tiyenne. අපිට මේ month එකේ දැන් 25th මම පොඩි නිවාඩුවක් ගන්නවා, right? Since it is the Christmas and the end of the year, right? And the 1st of January ගොඩක් වෙලාවට මට family gatherings වලට settle වෙන්න වෙයි ළමයි. එතකොට a weeks දෙක most probably we won't be able to do the class, right? ඕගොල්ලෝ දැන් January month එකේ payment එක කරනකොට you better do a half payment, right? මොකද අපිට December month එකේ කරගන්න වෙන්නේ දවස් 3ක් විතර වගේ තමයි එතකොට, right? Since we are like way too ahead, right? අපි දැන් 5 වෙනි පාඩමත් ඉවරයි, 6 වෙනි එක පටන් ගන්න තියෙන්නේ. So no worries to have some holidays, right? So yeah, let me see whether anyone has paid for the, yeah, some of you have paid for the December. So yeah. Yeah, yes. It's only Nikini who has paid for the December. So Nikini, in next month, you'll pay a half payment, Puta, right? Half of the class fee. Rest of you people, when you are paying for the December, pay in half, right? So you only need to pay 1,500 for the December as the December fee. Nikini, you can pay the 1,500 for the January when you are doing the payment, right? Please remind your mother or father, right? Others, you may pay 1,500 as the class fee for the December, right? So let's keep the date as the second week of the January to commence the physical class, right? Api himing yamu ara kene අවශ්‍යතාවය මූලිකව තියෙන කට්ටියව මම මුලින් අරගන්නවා. එතකොට හැමෝම එක පාට gather වෙන්නේ නැහැ. ජනවරි වෙනකොට තව මේක ඕකේ වෙයිද? ඔමික්‍රෝන් කියලා එකකුත් එනවා. ඒක කොහොම ස්ප්‍රෙඩ් වෙනවද කොහොමද කියලා දන්නේ නැහැ. Right? So take the message to your parents and we'll go like that. Right? Okay, so is everyone done with this? Anyone who is still writing this? Okay, so let's try one particular question. So let me look into the page table. Otherwise, I can't make the question for you. Right. So the question is this. I'll write the question over here. Find the physical address in decimal of the virtual address $24,600 by using the above page table. Okay, try it out, people. Now you know the drill, so give your best shot. ළමයි මේ ප්‍රශ්නේ අගට මෙන්න මේ තේරියත් ඇඩ් කරගන්න. Assume all the entries of page table as valid entries. Right? මං කියන්නම් ඇයි එහෙම ලියන්න හේතුව කියලා. Right, Lalindi, I receive your answer. Hold on, let me see. Yes, that's the one. Very good. Yes, others, how are you doing? Okay, Nikini, very good, very good. Nikini, පොඩි පුංචි තැනක් අවුල් කරගෙන තියෙනවා. කොබලන්න. Okay. ඔව් නිකිනි බලන්න මේ offset එක ලියපු පැත්ත. ඔයා match කරගෙන තියෙන එක හරියටම හරි. offset එක බලන්නේ තියෙන තැන් දෙක අනුව 24600 හැදෙනවද කියලා දුව. අන්න එතන පොඩි අවුලක් තියෙනවා. offset එක පැත්තේ digits දෙක දාලා තියෙන තැනේ තමයි වැරද්ද තියෙන්නේ. නැත්නම් mapping ඔක්කොම දේවල් ටික ඕකේ. Right? Very good. Right. Duli. Duli is disconnected. Divyangana, Osanda, how about the situation? Nalindi, since you are done, you can leave the session, Dua. Next week, we'll discuss the 2021 as well as we'll commence the network lesson as well, right? And I'll let you know when to collect the network tube people. Oh, Sandra, that's correct. Very good. That's the answer. Very good, very good. Ah, yes, Lalindi. Thanks for reminding me. We have to do the last part of the logic gate. So next week, we'll go through the 2020 question and the last part of the logic gates, right? Then after, we'll move to the sixth lesson. Okay, Lalindi, thank you. Divyankana Dua, do you need any help? And Nikini, did you find the incorrect place? Or Sandra, even you can leave, Puta, since you have done the thing correctly. Nikini, just try to convert your virtual address into, no, do it like this. Take a pencil and put the place values at the top of the virtual address. Virtual address page, virtual address එක ලියපු තැන උඩින් place values ටික දාලා බලන්න හරිද කියලා ඒ numbers ටික එකතු කරාම address එක එනවද කියලා. Divyankana Dua, let me know if you want a help, right? Yeah, Divyankana, where do you need the help? දැන් අපි කලින් හදපු විදිහටම ගියාද? What is the place that you are stuck with? Did you extract the 24,600 Dua? Did you extract it and see? Right, okay. So maybe that is the problem with you, Dua. Okay. So, like, are you struggling with the conversion, Dua? Is it the case? It's okay, Dua. I can assist you. Divyankana Dua, is it the place where you are struggling with the conversions? Okay, right. Just see whether is this the way that you are going to convert. So this is the easiest way, Nidu. 24,600. Bikini. Hold on. Okay. Am I getting anything wrong? Nikini, the place where you have gone wrong is it is 8,192. It should be the values that you were writing for the places is wrong. It's 8,192. That makes 16,384. That is where you have misleaded. Right, then hariyai. Then balannako karla. Right, Divyangana, you were dividing this by 2, right? You know how to convert a decimal value into a what we call the binary value. This is the way that you are going to do it. So when the decimal value is given, you divide it by 2. So it's 12,300. And we are going to write the remainders. Were you going through something like this, Dua? All right, okay. So then you divide it 2 again. So 6, 150. 0 is remaining. Right? So do it 2 again. So it's 3, 0, 7, 5. 0 is remaining. Divide by 2. 1,000. It is 1. This is 5. 3, 2. 1 is remaining. Doing by 2 again. Yeah, I have made the mistake. This is going to be the 7. That's right, Nikini. Yes, yes, that's correct. So you got that. Okay, okay. Be careful with the place values, right? Okay. So you can leave Dua. So Divyangana, are you getting what I'm doing here, Dua? Right, Nikini, thank you. Right. So I'm divided by 2 again. It's going to be yeah, 7. For 13 it is 6. For 17 it is 8. So 1 is remaining. Again 2. 384. 0 is remaining. Again 2. 192. 0 is remaining. Again 2. 96. 0 is remaining. Again 2. 48. 0 is remaining. Again by 2. 24. 0 is remaining. 12 and 0 is remaining. 6 and 0 is remaining. 3 and 0 is remaining. 1 and 1 is remaining. Dua, did you came up to this point? Great. So that means you should have the answer. How are you getting the answer? You can start it from here, Dua, right? Then Duwata mehema aragena මේකේ remainders ටිකත් එක්ක ලියන්නත් පුළුවන්. Or else you can divide 1 by 2 again. Then you can say 0 and 1 is remaining. Then you can write, or you can consider only the remainders from bottom to top. එහෙම යන්නත් පුළුවන්. Is that clear, Dua? Yeah. So when we are writing it, we should write from bottom to top. So the answer is going to be 1, 1. And how many zeros? 1, 2, 3, 4, 5, 6, 7, and 8. Right? Then again, there is more. I have missed some. Right? So 1, 1, 0, 0, 0. Now this is the address that you are going to have. Is it clear? Or were you struggling about writing this, Dua? යට ඉඳලා උඩට ලියන එක දුව උඩ ඉඳලා යටට ලිව්වද? එතනද ගැටලුව උනේ? දිව්‍යාංගනා දුව මයික් එක ඔන් කරගන්නකො. එතකොට කතා කරන්න ලේසි. දුව කොතනද පැටලුනේ? මේ ආන්සර් එක ලියන එකද? නැත්නම් මෙතනට ඇවිල්ලාද හිර උනේ? right, okay. දැන් මෙතනින් පස්සේ දුව කරන්න තියෙන්නේ අපි අර calculations වලදී දුව හොයාගත්තනේ මේ page number එකට bits 3ක් අයිති වෙනවා. දුව මේකේ calculations හොඳට කරලා තිබ්බනේ මට මතකයි. last time අපි අර ලොකු ගොඩක් මේවා ටික කරනකොට right ඒ අපි අර equations පාවිච්චි කරලා කරන වෙලාවෙදී වගේ අපි හොයාගත්තනේ offset එකේ bits 12ක් තියෙනවා page එකේ bits 3ක් තියෙනවා කියලා. ඒක තමයි දුව මෙතනට පාවිච්චි කරන්නේ. ක්ලියර්ද දුව? එතකොට අපිට බොහොම ලේසියෙන් මාජින් එක මෙහෙම ඇඳ ගන්න පුළුවන්. ඇඳලා කියන්න පුළුවන් මේ ටික page number මේ ටික offset කියලා. ඒ page number එකයි offset එකයි වෙන් කරන විදිහ ගැන clearද පුතේ? right. දුව එතකොට හිර වෙලා හිටියේ කොතනද? right, දැන් ලේසි වැඩේ. දැන් තියෙන්නේ මෙන්න මේ 110 ගෙන් represent වෙන number එක හොයා ගන්නවා. right, okay. හරි. දැන් තියෙන්නේ 110 ගේ තැන හොයාගන්නවා page table එකෙන් එයාට අදාළ frame එක replace කරනවා 110 කියලා කියන්නේ 6 නේ right 110 කියන page එක කියලා කියන්නේ 6th page එක එතකොට අපේ question එකට අදාළව 6th page එකට තියෙන්නේ 000 frame එක right එතකොට කරන්න තියෙන්නේ 110 කියන එක්කෙනාව 000 ගෙන් replace කරන එක. එතකොට මුල් කොටසට 000 කියලා එනවා. then after අර offset එක එහෙමමයි. එතකොට මේක තමයි අපිට එන physical address එක වෙන්නේ. clear ද දුව? right okay good හරි දුව මම එහෙනම් අදට මෙතනින් නතර කරනවා next week එකේ අපි ගාන කරනකොට බලමු right okay right okay දුව thank you very much